All right, guys. It's Friday before break. Yay, us. And more people are here than I thought. Riley's gone, and Ben is gone, and Antoine is gone, and Aiden is gone. Okay. Real quick review. Did you remember, what do you remember off the top of your head without looking? Do you have a definition? I know it's on the slide, but I talked about it, remember, as winners out of total possible. Winners doesn't mean, it could be you want to not roll a 7, right? Something. So, but it just means the ones that we're going to count as winners. All right. And then experimental, we really don't have to worry about. Today we're going to talk about a few of these things, but mostly these last 2 learning targets about calculate the number of possible ways an event can occur and the probability of an event using permutations and combinations. All right. I threw a slide in here about cards in case we need it, but we are on worksheet 2. This question says your doctor's going over the statistics of a risky operation. The surgery has a 25% failure rate. If the surgery works, then there's a 17% chance of infection. The surgery can fail and you can still get an infection 3% of the time. What are your chances of a successful and infection-free surgery? Okay, we have a lot of probabilities that we don't need, I think. What is, if we want a successful surgery, what rate of success is that, guys? Yes, good job. 75% successful. And if it is successful, what is the chance? Let's see. If this is what we want, right? If the surgery works, then there's a 17% chance of infection. So we want to be infection free. So that one would become what? 100 minus 17 would be 83%. Infection free when successful. So we have a 75% chance of surgery being successful and an 83% chance of not getting an infection when it was successful. Can anybody tell me what that becomes? 62%. Did someone else get that? It doesn't matter because you're not pushing sine, cosine, or tangent. Is that not right? 0.75 times 0.83? I got 0.6225, yeah? We're good? You shouldn't need parentheses, but all right. At a clothing store, statistics show that if you just buy pants without trying them on, you have a 30% chance of them being too tight, 10% chance of them being too loose. What is the probability you purchase pants that actually fit without trying them on? I think this is an easy one, isn't it? 100% chance that we're going to buy pants. 30% chance they'll be too tight. 10% chance they'll be too loose, which leaves what? 60% chance that they'll be good. You probably still won't like them, right? But all right. To meet state standards, Harlem does research and discovers that 80% of students need help with math, 70% of students need help with English, and 55% of students need help with both math and English. I think that this would make a good Venn diagram problem. How many of you feel like you have never really understood or done problems with Venn diagrams? Have you seen them a little bit? Yeah, but a little sketchy. When I look at this question, we have math and English, right? So we'll call this circle math and this circle English. But you want to start in the middle if you can. Do we know where the overlap is? My diagram is really too small here. I don't know if I can make this bigger, but what's the overlap in the middle? Who needs help with both? Yeah, so in this little middle right here is 55%. Now, 70% need help with English, but that 70% includes the 55%. Does that make sense? So 75% said, I need help with English. But part of those went on and said, I need help with both. So there's an overlap. All right. So 70 minus 55, is that 15? Did I do that right? 55, 65, 70, I think so, okay. 80% need help with math, but that includes the 55 that needed both. So 80 minus 55 is that 25%? Needed help only with math. Okay, so what is that total? 25, 55, and 15. $95, so only 5% are left over. Is everybody okay? Out of the 100% of students, only 5% said they didn't need help with anything. All right, what is the probability that someone needs help with math or English? Does anybody know what that's asking? No, and that's the confusion. That was my first take as well. But if you need help with both, and I ask the question, do you need help with math or English? You're going to say yes, okay? So math or English means math or English or both. So what did we total those to be? All right, is there more questions about this problem? Or is that the only probability it's asked? Just that, right? Okay. All right, conditional probability, particularly with a table, is always on the SAT. It's some kind of table questions about this. It says conditional probability is usually when you use the word given, okay? Find the probability of an event happening given the fact that another event has already happened. Now, when it says given, it means there's a different denominator. Let's just go through this question, see if we can figure these out logically, and then we'll talk more about given. So there was either executive workers or production workers. They were Democrat, Republican, or independent. They totaled all the columns, and how many people did they talk to total, guys? 140. Everybody okay with that? Okay, so how many people said they were independent, or the probability of picking an independent person if we were doing a random thing here? 17 total independent out of 140. Everybody okay? And picking a production worker? Yeah, 92 out of 140. If it was a quiz, you'd reduce these, but for your notes, it might make sense to just leave it so you knew where you got the numbers. All right. We did this a little bit yesterday with an or. It means you have to count everybody who's a winner, right? Independent or a production worker. So you have 63, 21, 8, and 9, all of these people. Does everybody get that? There's several ways you could do it. Probably the fastest way would be to take all the production workers and add these extra 9 independent people. Does that seem right? But you could definitely add up all three, 63, 21, 8, and 9. And is it 101? Is that what I'm... 101 out of 140? Again, because there's more production workers than there are independent, I would have just said 92 plus these additional 9 independent people. Okay. This is where it gets tricky. And the big thing to remember, write yourself a big note here. Given means you are changing the denominator. Okay, you're changing the sample, the amount of people you're talking to. So executive, given that they're Republican. So given that they're Republican means they have to be out of this 55 people. Okay? So you can only choose from those. So how many are executives out of those 55, guys? 34. All right. Independent, given a production worker. So given a production worker means the denominator is what? 92. And independent was 8. And that would reduce, but again, for your notes, I think it's better to just know where it came from. We feeling okay? You're going to be able to look back at your notes and understand, because those are on today's Delta Math for sure. All right. I'm not going to ask you a tree. We talked a little bit about this yesterday. You could do this one of 2 ways. If you're going to flip a coin and roll a dice, why don't you let me draw them and then you decide which way you want to write it on your paper? You could go, I'm going to roll a 1, 2, 3, 4, 5, or 6. And then off each of those, I'm going to do heads or tails. Okay, I don't know why I went heads, heads, tails, tails, heads, whatever. All the way down. Or you could do a giant, I'm going to roll either heads or tails, and then off of those, I could roll 1, 2, 3, 4, 5, or 6. I don't know which is easier to do. I guess I feel like that second one is faster than going heads or tails, heads or tails. Heads or tails. Is it a different number of end results? No, it's the same. Okay. There's 12 things out there in the universe because it's either 1, 2, 3, 4, 5, 6 with a head or a tail. All right. I'm not going to ask you to do one of those on the quiz. I don't want to grade it. Okay. Now we're on 2B. It says, in a class of 30 students, we have to choose a president, a vice president, and a secretary. The student can only hold one position. How many different outcomes are possible? All right, this is, they call this counting principle. I don't know if I would call this a counting principle, but there's 3 slots. How many people are we talking about choosing out of for the first slot? Doesn't matter if we started with president or secretary. There was 30 people to pick from. And then when we went back, they can't be the same. So then there would be 29 people to pick from and 28 people to pick from. How do you know it's not a fraction here? It says how many different outcomes. It doesn't say what is the probability or something, okay? Does that make sense? So we should have a big number. I don't know what that answer is. Two, 4, 3, 6, 0. Did someone get? Okay. I want to revisit this question in a couple minutes, so help me remember to come back here. Oh, I don't think I put this slide in here, but you guys should have it. Revisit the 4 children problem. Create a tree showing the possible. Oh, gross. No, we're not doing this. I showed you yesterday the tree diagram of boys and girls. Remember the whole 4 kids. This is a good way, this is a good moment though. Without looking back, can you remember how we figured out how many possibilities there was? So the first kid could have been born, what did we do? It was a gender question, my apologies, but the first, how many choices are there? First kid is either boy or girl. Second kid is either a boy or girl, boy or girl, boy or girl. So there was 2 to the 4th or 16 options. That's really all it asks. How many possible combinations are there? Not sure why that question is in there, but that's a good moment to put a cute little emoji, right? Thing. All right. The next thing we're going to talk about requires a factorial. And I need you to grab your calculator. Well, let me explain what a factorial is first while the calculator is opening here. A factorial is, as I put on this screen, a factorial is a number times, like if you told me 17 factorial, it's an exclamation point is the symbol, and what it stands for is 17 times 16 times 15 times 14 times 13, all the way down, okay? So at some point our calculator is definitely not going to do these because it's going to be too big of a number. But what it is used for, in my mind, an easy explanation for you is our class, say, has 17 people today. If we're going to line up at the door, how many different ways can we line up? Well, when I go to pick somebody who's going to be first, there's 17 of you to pick from. When I go back to pick somebody who's going to be second, there's going to be 16 of you to pick from. If we're all going to line up, it would go all the way down to 1, okay? So that's a 17 factorial. I don't know if our calculator will do that. Let's check. So factorial is under the math button, but it is over under probability. What do you know? So we're going to scroll to the right or left till you get to this probability one. And then it's choice 4. Now we probably were supposed to put the number 17 in first, okay? So I'm going to put 17 and then math and over to probability. Are the older calculators seem okay? It put it in scientific notation, right? It's too many, it calculated it, but it put it in scientific notation because it's too big of a number. If we tried like 50 factorial, I think we'd just get an overflow error. Oh, I didn't, here. Let me go back and try. Did anybody see how far it went before it was too big? Oh, it's still doing it. Okay. Let's see, 99 factorial. Does it still do it? At some point, I know you get an overflow error. Did it get it for 99 factorial? Was an overflow error? Okay. That was just for fun. Okay. It's possible to freak your calculator out. How's that? We are actually going to use these buttons in that probability menu. So if you want to write yourself a note next to this section, it is math. And then you want to go over a couple times till you get to the probability menu. And that's where we're going to find the permutation button that we're going to talk about, which looks like this. And you're going to put numbers in both of those places. But let's talk about what permutation means. This is the formula for permutation, but you're not going to need to know it because this button will do it for you, okay? A permutation is when n is the number of things to choose from, and we are going to choose r of them without repetition, okay? That means that we are counting things differently. So picking Bob and then Susie is different than picking Susie and then Bob. Permutation, this is the way I remember it, it is priority matters. Okay, you cannot repeat. Order matters, priority matters. It is a permutation question. It means Bob, Susie, Susie, Bob are counted two different ways, okay? A combination question has a fancier formula and is this C and CR. This is where the order doesn't matter. I think of this as a committee question. For example, if I'm going to pick, I hope I said it right a second ago. Did I say Bob, Susie, Susie, Bob counts as two different things? Okay. Because a committee question means Bob, Susie, Susie, Bob is the same committee, so it doesn't count them twice. Does that make sense? So if we're going to pick three of you to hand a $100 bill in this room, does it matter if you're picked first, second, or third? No, you get the $100 bill. If I'm going to pick three of you in this room, and one of you I'm going to give $100, one I'm going to give a 5, and one I'm going to give a 1. Does it matter to you which one you're, yeah, okay. So that's it's not always order matters. It's like they count differently, okay? So do we count every possibility differently? Or here you get like Bob, Susie, Susie, Bob is the same. And here it would count as two different. So combinations is a smaller number of choices. All right, these are in the menu I showed you, okay? If you have an older calculator, for example, we're gonna say out of the 17 of you, I'm gonna pick 3 of you to give 100, 5, and 1, okay? So we're gonna go 17 first on the screen. If you have an older one, you have to do it first. Then go to math. This is where order matters, so we're gonna pick P. So I'm gonna go down to number 2 and hit enter. Now, notice that on the newer calculators, it actually puts the 17 down in that box. On the older ones, it doesn't, but it'll still work. How many people did I say I was going to choose? 3 people. So I got 4,080 different ways that I could pick those 3 people if there were 17 of you, okay? We'll talk about this again. Let me show you the difference though. Let's do it again. 17, math, arrow to the right, to NCR, and then choose 3. Is it not working?
I didn't put the 3 down, so I was giving you.
Okay. Now it worked? Okay. Do you see it's significantly less number of ways I can pick 3 of you if I'm not counting those 3 of you differently? All right. Think about it this way. If it was a probability question, the chance that you get $100 is significant. If I'm only giving it to one person, is significantly smaller than if I'm going to give it to 3 people, right? All right. We are going to talk now a little bit more about those. Oh, I wanted to show, if you have a brand new calculator, the spiffy ones, there's a shortcut. I believe it's Alpha Window. Alpha Window gets you to these three things really quick, okay? I don't know which calculators it works on, but Alpha Window, then you can pick 7, 8, or 9 a little bit faster, okay? So if yours happens to work, you can write yourself a note that Alpha Window also works. All right. Is this on my next slide? Is there something more I need to write here? Oh, let's talk about exactly what N and P represent before you forget, okay? You might want to just write somewhere next to these that N is the total number of things to choose, and the R is the number you're choosing. So the bigger number always has to go in first, though sometimes they could be equal, right? Out of 17, I'm going to choose all 17. Just I want to know how many different ways I could order them. All right. Anybody need more time? All right. Oh, it was not on that slide. So let's go back and try to find this question that I've covered up. All right. You have 32 people in your class. You're choosing a team of 3. How many possible ways can you choose the team? I know it feels like the order matters when you're picking for a team. Okay. But if it's a group of people, does it really matter how you were put on the team? Do I want to count A, B, C, B, A, C, C, A, B all different? Or are they the same team? Okay. If they're the same team, then what is it called? Yeah, it's a combination. So out of 32, a combination of 3. Tell me what you get when you use that button. Anybody get an answer? This is what you got? This is what you get if you multiply these. Why is this not right? This is, if I pick everybody, there's 32 people to pick from, then 31, then 30, right? But this way counts picking A, then B, then C. It also counts picking B, then A, then C. It also counts picking C, then A, then B. It counts them all separately, right? So that's the difference, okay? This is a combination question. I'm just trying to help you understand what the difference would be and why it's that one. Number 2 says, how many ways can 8 students be placed in line? If you're lining students up at the door, let's be realistic here. Does order matter? It's a different way of lining them up, right? So we're going to go with order matters, which is a permutation. Now with permutations, I rarely use the button. You certainly can. We're putting all 8 of them in line, so it's 8P8. But it's also 8, 7, 6, 5, 4, 3, 2, 1. because there's 8 people I can pick to go first, then 7, then 6, then 5. So you could also just use 8 factorial, or you could type 8 times 7 times 6 times 5 times 4 times 3 times 4. Anybody get an answer? 4320, like 40320. Everybody good? Okay. In how many ways can you choose a committee of 4 boys and 4 girls? This is a complex one. If there are 20 boys and 20 girls to choose from. So let's just worry about the boys for a minute. It is a committee question. Order does not matter. Okay. So it is a combination question. So out of the 20 boys, we are going to choose how many? 4. And then out of the 15 girls, we are going to choose 4. I should show it on here one more time. You put in the first number first, so the 20, then go math, one way or the other over to the probability menu. We're using number 3, and it was a 4. And then 15 was the other one, right? And if you have this calculator, you could use this and choose 8 and 4. Now, what do you think we're going to do with those 2 numbers? Subtract, add. Okay, for every one of those 4,845 ways, couldn't you pair them with one of these? With any one of those. So we have to multiply these. Yes, any one of these can be paired with any one of these. It's like an independent probability question where remember we multiplied the probability of a heads times probability of a 6. We have to multiply these. Somebody tell me what you get. Just read it a digit at a time. Since we... Okay, someone else get those? Over 6 million ways. Awesome. Okay, and how many ways can I arrange my videos and DVDs on the shelf? If I have 5 videos and 7 DVDs, all the videos are going to go together and all the DVDs are going to go together. In my brain, if I'm going to put all the videos here, how many do I have to pick from for the first slot? 5, and then 4, and then 3, and then 2, and then 1, because there was 5 videos. Okay. And then I'm going to put all the DVDs. So I have 7, and then 6, and then 5, and then 4, and then 3, and then 2, and then 1. I would never ask you this question on a quiz, by the way. So 5 factorial, I might be able to do that in my head. 120 maybe? 7 factorial, I feel like we already did that one. I don't remember what it was. $50.40. Okay. So for these 120 ways, for every one of them, can I do one of these? I think so. I think because I can do these in a certain order and then these in a certain order. So I think we have to multiply. This is why I will never ask you this question, because I'm not feeling much confidence. But there's one more. Yes, go ahead. Oh, I got, no, you're good. 604,800. Someone else get that? Okay. I think that's not the final answer, though. Does anybody know why? I think it's twice that. Does anyone know why it might be twice that? Yeah, this is videos first and then DVDs this many ways. but we could switch the order of those all the way around. Yeah, I'm not confident in that answer. So I'm going to go with that's not a question I will ever ask, okay? We could photo math it and see what they said. All right, after spring break, we are going to do worksheet 3, 4, 5, and 6, all the circled problems. One day we're going to work on those. If you wanted to get ahead or you weren't going to be here that Monday, that's going to be the assignment. But today, it's Delta Math, okay? So grab your calculator or that little computer thing, Chromebook, and work on Delta Math the rest of the time.